Good afternoon, my YouTube viewers. In this series of videos, we're going to be talking about nonparametric tests. And basically, what a nonparametric test is it does not assume an underlying distribution of data. And so, the first nonparametric test we're going to talk about is the sign test, and it's used to test the median of a population. So we're going to write a Python program to carry out the sign test. And in this Python program, we're going to import three libraries. So we're going to import NumPy as NP, which is a numeric library that also creates NumPy arrays. And then we're going to import matplotlib.pyplot as PLT, which is a visualization library. And then we're going to import scipy.stats, import binom test. So scipy is Python's scientific library, and stats is a statistical module within scipy, and binom test is a function, is a model within the statistical model. So we're going to simulate paired data, and we're going to simulate before and after measurements. But before that, what we want to do is we want to set our seed. So basically what happens when you set your seed is every time you run the program, it initializes to the same values. So you do that by typing in np.random.seed, and you can type whatever number you want within the brackets. And before, we're going to define the variable before, which is np.random.normal. And so that normal means it's a normal distribution, brackets 50, 5, 30. So that means a mean of 50, standard deviation of 5, and a sample size of 30. And so these are your simulated before measurements. And then we're going to define the variable after equals before plus np.random.normal brackets 2, 3, 30. So this is the simulated after measurements. So we're going to perform the sign test. So differences equals after minus before. Positive signs equals np.sum, differences greater than 0. Negative signs equals np.sum, differences less than 0. And then we're going to make a null hypothesis. The median difference equals 0. So we're going to use the binomial test for the sign test. So the result equals binom test, brackets, positive signs, comma, n equals positive signs plus negative signs, comma, p equals 0.5, comma, alternative equals two-sided. And then we're going to print the results of the test. We're going to print number of positive differences, positive signs, and print number of negative differences, negative signs, and then we're going to print the p-value. So we're going to plot the results. So on this test data, the number of positive differences is 21, and the number of negative differences is 9, and the p-value is 0.0427. So p-value is probability, and the p-value is less than 0.05. So that's something to keep in mind. So we're going to plot the results. Labels equals positive differences, comma, negative differences. Values equals positive signs, comma, negative signs. And then plt.figure, brackets, fig size equals 6, 4. We're going to create a bar chart. plt.bar, brackets, labels, comma, values, comma, color equals green, comma, red, comma, alpha equals 0.7. The title is sign test, positive and negative differences. And the Y label is count. And the grid is axis equals y, line style equals dash, alpha equals 7. And then we're going to insert some code in here to put figures, put the percentages or the figures above the bar values. So the sign test is 21 positive and 9 negative. So that's your sign test. And the p-value is 0.042, but we haven't done a p-value test. It would fail you would reject the null hypothesis, but we haven't designed a hypothesis. We just assigned a sign test to see the positive versus the negative differences. So you'll see that you have more than double the amount of positive differences than you have the negative differences. So that concludes this video. The next video is going to be on another nonparametric test. So I hope that you decide to watch it.